The next topic is random variables. Okay, random variables is not the same as random numbers. Okay, random variables or a random variable assigns a numerical value, okay, a real number, to every possible outcome of a sample space. Okay, so that's the essence of it. So, for example, you have coin toss, H and T. Okay, H for head, T for tail. Suppose if you assign a numerical value, H equal to 1, T equal to 2, okay, then the random variable is 1 and 2. The random variable can take two possible values. So everything that is valid for the outcomes of a sample space is valid for random numbers. So which means random number is simply, I'm sorry, random variable. Okay, random variable. A random variable is one that takes on a value when an experiment is repeated. Experiment, remember, this is not a scientific experiment. This is just in the context of probability. So, an example here. Um, so, there are some examples of random variables in table 2.5. So here, X is number of Christmas trees sold. So it can be 0, 1, 2, and so on. So inspect 600 items, number of acceptable items. Again, 0, 1, 2, 3, and so on. So uh, a repetition of an experiment and outcome is a numerical value. So if the outcome is not a numerical value, then you have to assign a numerical value. For example, student response to a questionnaire. So strongly agree, neutral, disagree. And so this cannot be a random variable. Okay, this is the outcome of a sample space. You have to assign a number to it. Then it becomes a random variable. So one machine is inspected defective, not defective, or 0 or 1. Then that is a random variable. Okay, so you have to have a number. Okay, assigns a real number. Okay. Now, discrete random variable is one where the number assigned is countable. Okay, it can be infinity too. Countable infinity is another concept that you should be familiar with. Here, a random number, like for example, how many Christmas trees you will be able to sell. You have a stock of 500. How many can you sell? A stock of 50. How many can you sell? Okay, you can sell 0, 1, 2, 3, all the way up to 50. So that is discrete. Okay, that is a finite number of possibilities. Okay, or if you have a forest of Christmas trees, infinite number of trees, well, at least from practical standpoint. Okay, then how many can you sell? 0, 1, 2, 3, and so on and on and on and on without end. Yeah. Another example would be how many customer service calls will you get in one day? Okay, it can be 0, it can be 1, it can be 2, it can be 3. So the key here is your ability to count one value and the next value. So when you're able to count from one to the next to the next to the next, then that is discrete. Okay. All right. So what is continuous then? Okay. So here, okay. Continuous random variable by definition has infinite possibilities. So here, discrete random variables can be finite possibilities or infinite possibilities. Okay. In the case of infinite possibilities, the key is your ability to count one to the next to the next. Whereas continuous random variable is by definition infinitely possible, and you cannot count from one to the next value. So for example, the same customer service calls coming in. Okay, what is the length of time a customer service call will last? Okay, well, it can last 0 minutes because they call and immediately hang up. Okay, for example, so 0. What would be the next value? So 1 second. Well, if you say 1 second, I could say half a second. If you say half a second, I could say 1/4 of a second. Well, the point is that this is a continuous variable, so you simply cannot tell what that next value is. You can only say that it is greater than or equal to 0. It can take the all day or 0 or more. So you can only say this random variable can take greater than or equal to 0 minutes. Okay, so when you have a random variable that can take uncountable, so that is the key here, countable versus uncountable. If it is countable, it is discrete. It's uncountable, infinitely many values, then what you have is a continuous random variable. Okay. Now probability, or how do you assign probability for a random variable? Again, the same principle like what we've already discussed applies. So each random variable value, the basic principle is the probability for each value of the random variable has to be between 0 and 1. And when you add all the probabilities for all possible values of the random variable, then the sum should be equal to 1. So that is the key. And so let's apply this concept for the sample spaces that we have seen before. So an experiment of tossing a coin, all right, the sample space is head or tail, right? So now if you assign a random variable to it, and then you say, if you say x is equal to 1 if x is equal to 1 if outcome is head, and x is equal to 0 if the outcome is tail. So then we have a random variable, so x is 0 or 1. Okay, let's again format this to make sure that it appears nice and clean. Okay, and assuming that it is a fair coin, then we can assign probabilities of 0.5 and 0.5. Okay. Then this is a probability distribution for a discrete random variable. So x is a discrete random variable. There are only two possibilities. Okay. Then when you have a valid probability distribution like this for a random variable, then we can compute what is called the expected value of the random variable. That is given by multiply each value of x by its probability and sum them. Sum of x times probability of x. So x times probability of x. Okay. Then that sum is the expected value of x. Okay. The same concept holds for an experiment with a roll of a die. Okay. The sample space now is 1 through 6. The random variable is x equal to, we can, since these are already numbers, we can say x equal, if the outcome is 1, then x is equal to 1. If outcome is 2, x is equal to 2. Okay, so that's your random variable. So now we have 1, 2, 3, 4, 5, 6. So the probability is, again, assuming that it is a fair die, 1 over 6. Let's decrease the decimal places to 4 decimal places. All right. Now this is a valid distribution because the probability sums to 1. So now if you go x times probability of x, okay, then the expected value of x is the sum of x times probability of x. So this could be like if you get a 1, you get $1. If the outcome is 2, you get $2. The outcome is 3, you get $3, and so on. Then in this experiment, the expected value of one roll is $3.5, $3.50. So that's the expected value of X. Now let's look at another example of discrete probability distribution. Suppose we have 100 students in a class and there was a quiz, and the quiz consists of 5 very difficult algebra problems, and the grade on the quiz was the number of correct answers. So when you have 5 problems, and the theoretical range could be 0 through 5. Okay, 0 problems, right? 1, 2, 3, 4, 5. But of that 100 students, nobody had 0. So the possible values, let's say, go from 5, 4, 3, 2, 1, and these are the number of students getting each of these scores. Okay. Then we can estimate the probabilities using the relative frequency approach that we did previously. So that will be that divided by the total number, and remember this has to be absolute referenced. Let's adjust that. All right. Now the sum, okay, you can copy it. So that's 1. So that's, we verified that it is a valid probability distribution. Now you do X times probability of X. That will give you the expected value. So sum that. Copy that like that. So that's the sum. So the expected score is 2.9.